Assalamu alaikum and good day everyone. So for today we are going to proceed with the next subtopic, which is the second properties of inverse Laplace transform, which is first shift properties. Okay, so in my previous video I already teach you on how linearity properties works and finding the inverse Laplace transform. So now we proceed with the second properties. Okay, before we proceed with the first shift of inverse Laplace transform, let us recall back first shift of Laplace transform. Okay, let's consider your ft is equals to t exponent to t. So you know that for you to get your fs here, you need to use first shift properties. Why? Because one of the function is exponential function, so another function can be any function. Okay, so in this case your ft is equals to t. Okay, so to solve this one, you need to know what is your a. So your a is equals to 2. Okay, where did you get your a? From the exponent. The next one is you find the Laplace of ft. So Laplace of ft, since your ft is equals to t, so Laplace of t is equals to 1 over s squared. So the last step, you replace s with s minus a. So you have s, change it to s minus 2. So therefore, Laplace of t exponent to t is equals to 1 over s minus 2 the whole thing squared. Okay, so this is first shift properties of Laplace transform. So for first shift properties of inverse Laplace transform, we are doing the reverse process from here to get this function ft. Okay, so as you can see here, your fs here is in terms of s minus a. Okay, so by definition, if your Laplace inverse of fs is equals to ft, so here you have s minus a. So the inverse of fs minus a is equals to exponent at Laplace inverse of fs. So why you have exponent here? Remember when we learn first shift properties of Laplace transform, I told you it must be a multiplication of two functions and one of the function must be exponential function, which is exponent at. So that's why we have exponent at here. Okay, and this one is your ft, right? So if you inverse of fs, so you will have your ft. Okay, so when you need to apply first shift, when you have s minus a term. Okay, so I divide this one into two cases. So let's consider the first case. Okay, so case 1, this is just me who divide this into case 1, case 2. Okay, so case 1, I divide it as, if you have for the denominator part, you have s minus a to the power of n, where your n is greater than 1. Okay, for the numerator part, you have any constant. Okay, any constant. So either in this form or in this form, s minus a, if you have squared plus something here, like say 3, like say b. Okay, and this one here any constant. or you can have here minus. Okay, so let's take a look at the example so that you can know what I mean by this one. Okay, so let's say you have this function. Your fs is equals to 5 over s plus 2 to the power of 3. So as you can see, this one you cannot get directly from the table. Why? Because in the table of the Laplace transform, there is no such thing as s plus a, the whole thing to the power of n. Okay, what you have is just s, or s squared, or s minus a. Okay, you don't have like this form. Okay, so that's why we need to apply inverse first shift. Okay, remember this one. If your fs in terms of s minus a, so therefore you need to apply first shift properties. Okay, so you need to define what is your a. Okay, so in this case you have s plus 2. Okay, s minus a, what you have is s plus 2. So you know that your a is equals to negative 2. Okay, so the next step is, so for you to get the inverse of Laplace inverse of 5 over s plus 2 cube is equals to, so what is your constant here? 5 is your constant. So what you need to do with the value of 5, you need to factorize. Okay, so factorize 5. So what actually you need to find is the inverse of 1 over s plus 2 the whole thing cube. Okay, so as you can see here, this one is similar to the first case here. Okay, where for the numerator part can be any constant. So since I already factorized 5, so I left with 1. For the denominator part, you have s plus 2. So you know that your a is equals to negative 2. Your n is equals to 3. Okay, so therefore by using first shift properties, you will have exponent Laplace inverse of this one, which is your ft. Okay, so your ft is equals to 5. So first you need to have the exponential term, exponential function term. Okay, exponent at, refer to this one. Okay, exponent at. Okay, so what is your a? Your a is equals to negative 2. So you will have exponent negative 2t. Okay, Laplace inverse. So as you can see here, when you have the exponent, you already have the exponential term. S minus a you will replace by s. Okay, so here you will have 1 over s cube. Okay, when you have the exponential terms here, this one, so replace s minus a with s. Okay, so that's why this one is s plus 2, so you will have s, so the whole thing is cube, so you will have s cube. Okay, so how to get the inverse of this one? As you can see, you can get directly from the table, but but before that you need to do some modification. Why? Because here, what this is your n plus 1. Okay, by now you should be able to guess if you have in this form what will be your FT. Okay, if you still cannot guess this one, you need to go to my previous video and watch it again so that you understand that one first. If not, you will have a problem here. Okay, so for this one, you know that your n plus 1 is equals to 3. So what is your n? Your n is equals to 2. So supposedly, what is the value for the numerator part? It should be 2. Isn't it? Because this one will be t to the power of 2, t squared. So, you need to multiply by 2 factorial. You need to divide by 2 factorial. Okay, remember this one when you have n factorial, the inverse of n factorial over s n plus 1. So you will have t n. Okay, so supposedly if your n is equals to 2, so numerator part should be 2 factorial. So if you multiply by 2 factorial, then you need to divide by 2 factorial. So therefore, your FT is equals to 5 over 2. So this one will be t squared. Exponent negative 2t. Okay, so this is final answer. Okay, so let's just recall back. So the first thing first, you know that you cannot get this one directly from the table. So that's why you need to apply properties of inverse Laplace transform. Okay, so linearity properties does not work here for you to get directly from the table. Linearity properties just work for you to just factorize 5. Okay, so if you just factorize 5, you still cannot get this one from the table. Okay, so that's why you need to apply first shift properties. Okay, so for first shift properties, if you have s minus a term, so you will have exponent at. Okay, so exponent at, so exponent, so what is your a? Is from here. Okay, so generally is s minus a. So what you have is s plus 2. So you know that your a is equals to negative 2. So you will have exponent negative 2t. Okay, so therefore you just need to find the inverse of, since you already have the exponential term here. So s minus a will be replaced by s. So you will have 1 over s cubed. Okay, but this one you still cannot get directly from the table, because if your n plus 1 is equals to 3, your n is equals to 2. So it should be numerator part is 2 factorial. Okay, so therefore multiply by 2 factorial, then you need to divide by 2 factorial. So then this is the answer. Okay, and student might ask why we need to have these exponential terms. Because remember, when we are doing first shift properties of Laplace transform, okay, the condition is multiplication of two functions and one of the function is exponential function. Okay, so that's why we have the exponential term here. Okay, and where did the a come from? From s minus a. Okay, so your a is depends on this one. Okay, so let's take a look at a second example. So let's say you have your fs is equals to 3 over 2s plus 5 to the power of 3. Okay, so this one here. So again, for this problem, you cannot get directly from the table, and you have a constant 3 here, so you can factorize it. Okay, so you will have the inverse of 3 over 2s plus 5 cubed is equals to 3 Laplace inverse 1 over 2s plus 5 cubed. Okay, be careful. You cannot simply define your a here. Why? Because this is not s minus a term, because you have a coefficient of 2 here. Okay, the problem is because you have 2 here, so you cannot, from here you cannot simply get your a. You need to do something first. Okay, it's different from the first problem, because this one here is clearly s minus a term. That's why you know that your a is equals to negative 2. But for this one, you have 2s, so you need to do something first. Okay, remember during my previous video, if you have any coefficient more than 1, you need to factorize. But be careful if you want to factorize this value, because you have a bracket here to the power of 3. Okay, before this you have this kind of problem. So if you factorize, then you will factorize 3 over 2, isn't it? But now you have this expression, which is the whole thing to the power of 3. So if you want to factorize the value of 2 here, you need to do 2 to the power of 3 first, then only you can factorize. Okay, so therefore you will have this one, 3 over, so 2 to the power of 3 is equals to 8. So 3 over 8, the inverse of 1 over, so this one will be s plus 5 over 2, the whole thing cube. Okay, so you should now be able to do this one. Okay, because I already teach this one in my previous video. If you factorize these two out, so the second term will be affected. Okay, you have to do something. If not, you will never get the same function as before. But for this case, why here is 8 instead of 2? Because you have cube here. So if you factorize 2 to the power of 3, then you will have 8. Okay, so now as you can see here, this is case 1, first shift inverse. So what is your n? Your n is equals to 3. Your a is equals to negative 5 over 2. Okay, so from here you know that your a is equals to negative 5 over 2. So therefore the inverse of this one, which is your ft, okay, if this is your fs, so therefore your ft is equals to 3 over 8, so exponent at, so negative 5 over 2t, inverse of, so since we already have the exponential term here, so s minus a will be replaced by s. Okay, so s minus a will be replaced by s, so you will have 1 over s cubed. Okay, so here s minus a replaced by s, so you have s plus 5 over 2, so this term replaced by s. You can only replace this term to s if you have the exponential term. Okay, so the same problem as before, this is s cubed, so for you to get t squared, this is your n is equals to 2. Okay, so again here n plus 1 is equals to 3, so your n is equals to 2. So supposedly you have to multiply by 2 factorial, and this one, the whole expression here 3 over 8 need to divide by 2 factorial. Okay, so therefore your answer will be 3 over 16 t squared exponent negative 5 over 2 t. Okay, so the last one. Let's consider your fs is equals to 2 over s minus 4 squared plus 4 over s plus 2 squared plus 2. Okay, by looking at this expression, at this function, I think you can guess what is your ft. Okay, because if you take a look at the table of the Laplace transform, okay, so this one will be t in terms of t. Why? Because your n is greater than 1, so you will use this one. Okay, the second one here, for the numerator part you have a constant, and this one is plus, so obviously this one will become a sine function. But the problem here is that, what is your problem here? Your fs is in terms of s minus a, so that's why you cannot get the answer directly from the table yet. You have to do something first. So for both function you need to apply first shift, inverse, okay, first shift. So let's do the first one. So this is the first one, and this is the second one. Okay, we'll solve it one by one. Okay, so for 1, you need to get the inverse of 2 over s minus 4 squared. Okay, so 2 is a constant, so factorize 2. So you need to find the inverse of 1 over s minus 4 squared. So this one is already in terms of s minus a term. So get the value of a. So you know that your a is equals to 4. Why? From s minus a, and what you have is s minus 4. So that's why your a is equals to 4. So therefore, the inverse of 2 over s minus 4 the whole thing squared is equals to 2. Okay. So you need to apply first shift. So remember, when you have first shift, when you have to apply first shift properties, you need to have the exponential function term. Okay. So 2 exponent at. So what is your a? Your a is equals to 4. So 2 exponent 4t. So inverse of, so remember, when you already have the exponential term, so s minus a will be replaced by s. So you will have 1 over s squared. Okay. S minus a will be replaced by s. So therefore you will have, so this one is directly from the table. Why? Because if your n plus 1 is equals to 2, so you know that your n is equals to 1. So you already have 1 here. So you don't need to multiply and divide by a value of constant. Okay? Because this one is equals to this one. Okay? So therefore you will get 2 t exponent 4t. Okay, so this is for the first function. Okay, for the second function, you need to find the inverse of 4 over s plus 2 squared plus 2. Okay, this is also first case because you just have the s minus a for the denominator part. Okay, although you have plus here or minus here or another value of constant here, as long as you just have one terms of s minus a and that term must be in the denominator part. Okay, so for this case you need to factorize 4. So you will have 4 inverse of 1 over s plus 2 squared plus 2. Okay, so where can I get the value of a? The value of a for power, exponential power, is from here. Wait, is from here, not this one. This is coincidentally the same value, 2 here and 2 here. Okay, but for you to get the a for exponential term is from s minus a. Okay, so you have s minus a, so what you have is s plus 2. So you know that your a is equals to negative 2. Okay, so therefore the inverse of 4 over s plus 2 squared plus 2 is equals to 4. So we will have exponent at, so exponent negative 2t. So inverse of, now s minus a will be replaced by s. So this one is 1. So 1 over, this one is s plus 2. So you will have s squared plus 2. Okay, when you have the exponential term, so s minus a, s plus 2 need to replace by s. So that's why you have s squared here. Okay, so this one you cannot get directly from the table. Why? You know that this is sine function. Okay, when you have a constant for the numerator part and for the denominator part, you have plus here. Okay, but take a look at this one. Your a squared and this is your a. So now by looking at your function here, you know that your a squared is equals to 2, which is this one, referring to this one. Okay, so your a is equals to sed 2. So supposedly for the numerator part, it should be sed 2. Then only it can be sine function. Okay, so therefore you need to multiply by sed 2, and this one you need to divide by sed 2. Okay, remember every time we multiply by a constant, we need to divide by the same constant. And you need to know where to apply this one. Not all the time you need to multiply and divide. As you can see for the first function here, I don't do anything here. Because why? N is already 1. And you have 1 here. So you don't need to multiply by a constant. Okay, but for this case your a is equals to sed 2. So supposedly here should be sed 2. So multiply by sed 2, then you need to divide by sed 2. Okay, so therefore your answer will be 4 over sed 2 exponent negative 2t sine at sed 2t. Okay, so this is your first function, this is your second function. So you need to combine all these two functions. You cannot stop here because the question asks you this one plus this one. Okay, so therefore your ft is equals to because now you are given this is your Fs. So inverse of Fs you will have Ft. So therefore your Ft is equals to 2t exponent 4t plus 4 over sec 2 exponent negative 2t sine sec 2t. Okay, that's all. So we are done with the first case of first shift inverse. Okay, I remind you, it's just me who divide this one into case 1, case 2 for you to understand better. Okay, because as you can see in your textbook, in your textbook there is no such thing as case 1, case 2 for first shift inverse. Okay, I divide it so that you can know the pattern of the problem. Okay, so we are done with the first one, which is this one. So in my next video, I will teach you the second case of first shift inverse. Okay, so stay tuned. Okay, thank you. Assalamualaikum.